All right, welcome to the hopefully final bit of recording I'll be doing in my basement for a while. So, we introduced this flowchart last time in the last recorded video, in which I proposed this strategy whenever you want to solve degree 2 polynomial inequality. First, solve the equality. One of three things will happen. Either you'll have two solutions, one solution, or no solutions. If there are two solutions, then you can pick three sample points between and beyond those solutions, decide exactly where the thing is solved. If there's one solution, same thing, but it's easier. There's only two sample points you need to pick. No solutions, you just need to check a sample point. You can also do it by graphing. Let's see this in practice. Let's solve this inequality, x squared plus 3x is bigger than 4. In order to do that, start by solving x squared plus 3x equals 4. To do that, subtract 4 to the other side. That'll become x squared plus 3x minus 4 equals 0. All right. In order to solve that, well, pick your favorite strategy. I'll use the quadratic formula. X equal to negative b plus or minus the square root of b squared minus 4 times a times c, which is negative 4, all over 2 times a. All right, so continuing on, 3 plus or minus the square root of 9. Double negative becomes a positive. Negative 4 times 1 times 4 is 16, all over 2. Carrying on, negative 3 plus or minus the square root of 9 plus 16 is 25 over 2. Negative 3 plus or minus square root of 25 is something you actually know. It's 5 over 2. And now we're set, right? Negative 3 plus 5 will be 2 over 2, or negative 3 minus 5 is negative 8 over 2. So the solutions to this are 1 or negative 4. So there's step 1 done. My space management was not great. Step 2. Let's pick some sample points. So I found the two solutions to this are negative 4 and 1. Pick some sample points. It looks like one number that lies between these two is 0. X equals 0 results in 0 squared plus 3 times 0. Is that bigger than 4? It is not. So that says that negative 4 to 1 is not in the solution. None of the numbers between negative 4 and 1 could possibly be solutions to the inequality. Let's pick some more sample points. What's a number that's bigger than 1? 10. I like to go with something extreme like that so that the arithmetic is easier and it's more obvious if it's big. X equals 10 results in x squared, 100. 10 is easy to square. Plus 3 times 10 is 30. Is that bigger than 4? Yeah, it's 130. That's bigger than 4. So that tells me that 1 to infinity is in the solution set. X equals negative 10. You could do the same computation. Negative infinity to 4 is in the solution. And so now we are almost done. The only thing we don't know right now is should the endpoints be included or excluded. To do that, let's test the endpoints. And I'll give like the actual test, and then I'll just give you the heuristic. It's better than a heuristic, a rule. X equals 1. This will give me 1 squared plus 3 times 1. Is that bigger than 4? Well, no, because that would say that 4 is bigger than 4. Where did that x equals 1 come from? It came from this being equal to 4. So it has to be excluded because 4 is not bigger than 4. X equals -4, you can do the exact same work, but I know what the result will be. When you plug in x equals -4, you must get 4. Also exclude. So it looks like I know exactly what the solution is. It's everything before 4, don't include 4. Then don't include anything between -4 and 1. Don't include 1, include everything to the right of 1. Oh, hey, that looks like a union of two intervals. This has solution set -infinity to -4 together with 1 to infinity, excluding endpoints. So let's play a similar game. Without doing any computations, let's suppose you saw this on a multiple choice exam. Without doing any computations, which of these intervals are the solution to this inequality? So here's the strategy I'll take for this. All of these options have the same endpoints. So that means that this endpoint, x equals -1 plus or minus √5, must, assuming that the person who wrote this problem, which it was me, so chances are low that, well, no, chances are pretty high that there's an error. I've screwed things up a lot, but those two things must be the solution to equality. So there's no need to solve equality. The way the question is phrased tells you what the solutions to equality have to be. If the options were different, maybe that wouldn't be the case, but the options are what they are. Next, let's try to picture a graph. So √5 is like a little bit bigger than 2. So I know that these numbers are like those two numbers. No, that's wrong. There and there. There's -1 plus √5 over 2. Here's -1 minus √5 over 2. I know the graph goes through those 2 points. This is an upward opening parabola. The graph must look like this. Nice. Okay, I'm making progress here. In fact, I believe that I can just read off the answer now. It looks like this is solved by everything before this endpoint, because those are y values that are strictly bigger than 0. You exclude the endpoint because you want strictly bigger than. These are excluded. And then they start being included again. So this inequality is solved by this. Nope, opposite of that. Everything before -1 minus √5, everything after 1 plus -1 plus √5. Cool, nice. So the last thing that I want to hit is the idea of domain. Let's see how this interacts with domain. Let's compute the domain of this function. F of x equals the square root of 1 minus x squared. Here's how to think about square roots and domain. Well, whenever you're thinking about domain, you want to know like what are the valid inputs, what bad things can happen. So in this case, you see the square root, you think to yourself, well, what things are allowed to appear inside of the square root? Non-negative things. So in order for square root 1 minus x squared to be defined, you must have 1 minus x squared bigger than or equal to 0. So in order to solve this, you need to solve 1 minus x squared bigger than or equal to 0. And let's do it. Let's solve this inequality. So I guess step 1, solve equality. And this is certainly an easy inequality to solve. In fact, many of you, upon seeing it, may have already solved it. I'll go through and solve it. Maybe the strategy I'll take is I'll add x squared to the other side. 1 equals x squared. I'll take the square root of both sides. So 1 equals x, except whenever you undo a square with a square root, you get a plus or minus sign showing up. X is plus or minus 1. Oh, neat, it's solved. X equals plus or minus 1. Those are the endpoints of the solution. So now let's look at a graph. All right, 1 minus x squared. So that'll be a downward opening parabola. I know it has to go through these 2 points at 1 and negative 1. And I want to know when is the y value bigger than or equal to 0. Well, it looks like between is what I want. So 1 minus x squared bigger than or equal to 0 on negative 1 to 1 inclusive. But the whole point of solving this inequality is this is when that square root is defined. So the domain of square root 1 minus x squared is the interval from negative 1 to 1 inclusive. And let's do one last example. Again, this would have been like an exit quiz. So this would have been an I make you do it, and then once you have the right answer, you get to leave. But let's talk through it. If you already believe you have the right answer, then I guess you can jump to the end, and that's how it's an exit quiz. So doing so, you want to solve an inequality. Right? What things can you see inside of this square root? Non-negative things. So you must have x squared minus 2x plus 10 bigger or equal to 0. Let's solve that inequality. To do that, solve x squared minus 2x plus 10 equals 0. Yeah. Let's solve it. And you know what? I feel like varying my strategies up, I'm going to use completing the square. So that'll be x squared minus 2x. This tells me that it looks like my b is negative 1. So b squared is 1. So I want to see a plus 1 there. I already see a plus 10, so I just have 9 more. Let's just pull out one of the ones from the 10. Equals 0. X minus 1 squared plus 9 equals 0. X minus 1 squared equals negative 9. X minus 1, nope, get rid of the squared by taking the square root of both sides, equals plus or minus square root of negative 9. Oh, that's bad. I see a negative in a square root. So that means x squared minus 2x plus 10 equals 0 has no solutions. And, well, if you're still feeling mystified by the there are no solutions to equality situation, let's flash back to the flowchart. If there are no solutions, let's pick one sample point. Depending on whether or not that sample point results in truth, or the inequality being true or false, the inequality will either be solved everywhere or nowhere. So let's pick a sample point. I'll pick a sample point of x equals 0. you get 0 squared minus 2 times 0 plus 10. Is that bigger than or equal to 0? Yes, because 10 is bigger than or equal to 0. So x squared minus 2x plus 10 bigger than or equal to 0 is always true. I guess you could say this in a different way. The solution to this inequality is negative infinity to infinity, but this inequality was exactly what we needed to compute the domain of this function. So the domain of this square root function is negative infinity to infinity. Excellent. And I'll stop there. I will see you in a perfect world in person tomorrow. Wonderful. Ciao.